So let's look at how we quantify the benefit when we're making decisions, right? We look at the extra benefit, the marginal benefit, and the marginal cost, the extra cost. We weigh them, we make decisions. So we want to look at the marginal benefit and how do we quantify that? How do we turn that into numbers or represent that graphically? What we're looking at here is a graphical representation to quantify the benefit. So we're looking at indifference curves. This is a graph that shows all the combinations of two goods or services that yield the same level of satisfaction. And we learned in the previous video a term for the level of satisfaction. And what's that term? Utility. So this is a graphical representation of two goods or services that give us the same utility, the same level of happiness. Now let's look at the properties of indifference curves. Indifference curves have three properties. They have a negative slope, they have a convex to the origin shape, and they do not intersect or cross. So let's work through these to understand why. Remember that the indifference curve shows the combinations that give you the same level of happiness. So for example, would it make sense for an indifference curve to look like this? Well, if an indifference curve looked like this, then that would say that having 3 video games and 60 apps is the same to you, same level of happiness as 3 video games and 160 apps. Well, if you like phone apps, then probably having more of these is better. So we can't have an indifference curve that looks like this because more apps is better than less apps. Well, what about a indifference curve that looked like this? Well, this would say that having 90 phone apps and 2 video games is the same to us as having 6 video games and 90 apps. Well, if we like video games, then having more video games is probably better. So we want more video games, not less. So they can't be on the same indifference curve because they don't give us the same level of utility. All right, let's look at another scenario. What if we had an indifference curve that looked like this? So this indifference curve says that having 1 video game and 20 apps gives us the same utility, same happiness as having 6 video games and 180 apps. Well, if we like video games and we like apps, more of both is probably better than less of both. So they can't be on the same indifference curve. Indifference curves show the combination of 2 goods or services that give you the same utility, the same level of happiness. So when we look at our indifference curves, what should they look like? Well, they have a negative slope and they're convex to the origin. So what does that mean? To create an indifference curve, we need to pick a starting point. So let's start at 200 phone apps and 1 video game. So you have 1 video game, you've been playing it over and over and over again, you're getting kind of tired of it. You have tons of phone apps. You have so many phone apps that really, another phone app is meaningless to you. So what are you willing to give up of video games? What are you willing to give up of the phone apps that you have tons of to get 1 more video game? So when you don't have a lot of video games, to get 1 more is worth a lot to you, right? You're getting really tired of that video game. So you're willing to give up a lot of something you have a lot of to get something you don't. So when we only have 1 video game and we're going to 2, we may be willing to give up, let's say, 80 apps. So we're willing to give up something we have a lot of to get something we don't have. And remember, we're maintaining the same level of happiness. So we get one more video game, but we have less apps, and that way we're maintaining that same utility. If we had more of both, we'd be more happy. And that's a different indifference curve. An indifference curve is the same level of happiness. All right, you got 2 video games. You're now looking at a third video game. How much extra value does that third video game give to you? Is it the same as getting the second video game? Well, probably not, right? The extra value, as you start to have more and more of something, the extra value is going to be less and less. And that's why we get a downward sloping indifference curve, because when we go and get the next video game, we're not willing to sacrifice as much. Let's see, what are we willing to sacrifice? So maybe we go to 70 here. Oops. Okay, so now we're willing to give up 50 apps to get one more video game. So notice that we're sacrificing less to get something else because we already have a number of that something else. So we're giving up less apps to get the third video game. Well, what about the fourth? Well, now we have a bunch of video games to choose from. So the extra value of the video game, we now have less apps. So now you're going to be less and less willing to give up the apps because you don't have as many. So maybe now you're only willing to give up 30. So notice when we connect the dots, we have an indifference curve that's downward sloping. And notice that it curves. This shape is what is called convex. Okay. The opposite of convex is concave. So concave creates a little cave around what we call the origin, this 0, 0 corner. Convex turns away from that origin. So the idea here is that it's downward sloping because if we're maintaining the same level of utility, we can't have more of both. If you're the same level of happiness, then you're giving up something and gaining something as a trade-off and maintaining that same level of satisfaction. But how much we're willing to give up to maintain that satisfaction. Initially, we give up lots because we have lots. To get something we don't have lots of. But as we get less and less apps, they become more valuable to us, and we're less willing to give them up. So you'll notice here that the slope gets flatter and flatter because initially we're willing to give up a lot, and now we're only willing to give up a tiny bit as we get less and less phone apps. So indifference curves are negative slope, and they are convex to the origin. So you can see that convex shape. And it comes down to the fact that the more you have, the more you're willing to give up. The less you have, the less you're willing to give up. The slope of the indifference curve tells us the marginal rate of substitution. This is the amount of one good a consumer is willing to give up to get more of another good and maintain that same level of utility. Now let's compare that definition to the definition for the slope of the budget line. So the slope of the budget line told us about what? It told us about opportunity cost. So what's the definition of opportunity cost? The definition of opportunity cost is the amount of one good a consumer must give up to afford one more of another good. So the slope of the budget line, the opportunity cost, is about what we can buy, what we can afford. The marginal rate of substitution, the slope of the indifference curve, is about what we are willing to give up. Okay, so we have to look at what is the extra cost to get it, what is the extra value to us. So the marginal rate of substitution shows us the extra value to us of getting one more unit because it's maintaining that same level of utility. So what are we willing to give up to get it? That's the extra value to us. And we can then compare that, which we're going to do in subsequent videos, of how much it costs. How much does it cost to get one more? What we must give up to afford it. And so we can weigh the two against each other, the extra value to us, the extra cost to us. So we're going to be comparing opportunity cost and marginal rate of substitution. But it's very important to understand the difference between them. The budget line and the slope of the budget line was about money. When we graph indifference curves, there was no money involved in this decision. It was simply about quantifying the benefit, the value to us. Now you're saying when we do these indifference curves, well, where did these numbers come from? These numbers are based on individual value, preference. So everyone's indifference curves look different. My indifference curve for phone apps and video games are going to be based on how much I like video games and how much I like phone apps. Your preferences for video games will be different than mine. Okay, so we have to recognize that there are individual preferences. So we tend to look at markets and how much the group collectively values things. That's when we look at demand. We're going to be building up to that. But right now, as you draw an indifference curve, it's about what is the value to you. And that's going to be based on your own opinions and perspectives. But there are certain things that should hold true. Your indifference curve should be downward sloping because if you're getting more of both, you are happier. And we represent that something makes you happier by putting it on a higher indifference curve. There are an infinite number of indifference curves. Higher indifference curves are better because having more video games and more apps is better than having less. But anything on the same indifference curve gives you the same level of utility. And so it is downward sloping and it is convex. That is, you give up a lot when you have a lot to get something you don't have a lot of. And the less you have of it, the less you're willing to give up. So we get this convex shape. So what we have is that we have the law of diminishing marginal rates of substitution. That slope goes from steep to flat. That indifference curve is convex. And that's because when you have a lot of something, you're willing to give it up to get something you don't. When you don't have a lot, you're not as willing to give it up. This is the law of diminishing marginal rates of substitution. So when you're creating an indifference curve, yes, it's based on your preferences, but the indifference curves will have similar shape in the fact that they are downward sloping, convex. And because higher indifference curves show higher happiness, indifference curves can't cross. It doesn't make sense for an indifference curve to cross because by definition, indifference curves give you the same level of happiness. So if we're here on this indifference curve, then these 2 points give us the same utility, the same level of happiness. This combination of video games and apps gives us the same entertainment value. If we have a second indifference curve, anything on that indifference curve gives you the same utility, the same value. But the problem is if indifference curves cross, is that we're saying, let's call this A and B, are the same to us. And A and C, because they're on the same indifference curve, are the same to us. But B, because it's on a higher indifference curve than C, B must be better than C. So this can't happen. We have to have parallel indifference curves. Higher indifference curves make you happier. And that's because if you're getting more of both, it's better than less of both. So when we create indifference curves, let's see if I can find the page here. All right, it's not coming up. I'm having technical difficulties. So indifference curves have 3 properties. What are they? They are downward sloping, they are convex to the origin, and they do not intersect. And it's because our preferences are consistent, right? More is better than less. That makes them not intersect. And it's because of that law of diminishing marginal rate of substitution. The fact that we have a lot, we're more willing to give it up. The less we have, the less willing we're giving it up. That makes it downward sloping and convex.